Ahoy there makers, how you doing? Hope you've had a good day so far. So do you want to know all about the Pimoroni Tiny Effects, which is a tiny little microcontroller that you can add to your projects, your Lego projects, to bring them to life with sound and light? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots and bring them to life with code and have a whole load of fun along the way. Okay, let me just mute that and let's go over to our keynote and we can make a start. So yes, this is all about the really cool, wherever I put the tiny thing, Tiny Effects. So this is the tiny little microcontroller from Pimoroni, and we're going to be adding this to our Lego project today to add some sound and lighting effects. This is so cool and so tiny as well. The wires are just microscopic, and we'll see why that's quite important in a second. Cool. So yes, the Tiny Effects is an effects controller for LED dots and strips that can be found with third-party Lego compatible lighting kits, and it's based on the Raspberry Pi RP2040 microcontroller, and this is made by Pimoroni, and it's made in the UK, in Sheffield. So there's the two versions that they have of the. You can either just get the board on its own, or you can buy like the starter kit. So I've got both of these. And it also comes as a wireless version or like a non-Wi-Fi version. I've got both of those here as well. So I've got the Wi-Fi version actually plugged into the kit right now. As you can tell on the back, there's usually a little extra chip that just goes over that little pirate face there. Look how tiny this is. Absolutely microscopic. So let's have a look at some of the features, shall we? So it has 6 LED controllers, so we can control 6 of these tiny little LED strips. They come in 5cm or 15cm sizes, I believe. And they also come in like a single colour, or you can get RGB colour ones as well. The RGB strip controller requires a little plug-in with a little breakout board. We'll have a look at that in a second. This also has a speak output, which just makes your project so much more interactive when there's sound. There's a sensor connector, so you can connect up a motion sensor. I've got one hooked up on this one. If I wave my hand over here, it'll start playing a little sound clip. We'll do a bit more of a sound demo in a minute. Also has a stemma QT and quick connector, so you can connect up all other kinds of I2C connectors and sensors and things. It's got a tiny battery connector. I've got one hooked up to a battery box here. Again, it has a tiny little wire. It's almost, you can't see it on the stream there because it's so tiny. So you can have additional battery packs, or you could just power it by USB-C if you wanted to do that as well. So yes, this is the front side. You can also see there's a reset button on there. It's got a boot button. You can also use the boot button as a user button, so you can detect if there's a button been pressed to say stop an animation, something like that. And let's have a look as well. So yes, it's powered by the RP2040. That's a dual ARM Cortex M0 Plus running at 133 MHz with 264K of SRAM. This also has 4 megs of QSPI flash. So that means we can store plenty of quite large sound clips on there, and it's not a problem. I've got about 3 or 4 on the demo ready to go for you in a second. It's got a USB-C connector for power and for programming, so that can take 1 amp max for the LED lighting. And it's also got the reset and the boot buttons, so that you can use that boot button as a user button if you so wish. You can see the measurements there, 23.2mm by 31.2mm as well. Pretty sure that's some kind of Lego measurement. I was wondering if I had any Lego to hand to demonstrate that. I'm sure we can actually look on the ship in a second when we have a look at the model that we've got next to me. So yes, the Wi-Fi version also has the RM2 Wi-Fi module. That's the 2.4 GHz Wi-Fi and Bluetooth module. It's the official Raspberry Pi Bluetooth and Wi-Fi module. It's got 3.2 watt I2S mono amplifier with 2-pin Pico blade compatible connectors for attaching a speaker. These are really small connectors, so you might need some tweezers or some long nose pliers to get these in and out. It is a little bit fiddly. It's got the Quest connector, so that's a quick stemma QT connector. So if you've got any of them kind of connectors, I know Adafruit sell a lot of those, as well as Pimoroni as well. And SparkFun, I think, do quite a few of those quick stemma QT type sensors. And it comes fully assembled. There's no wiring required at all. You just plug things in to the nice little connectors. It's really easy. You get straight to the fun with this board. So here's the pins and dims. This one is, I think, did Chris create this particular diagram? It's very, very nice. We've also got a Lego car lover there on the on the live stream chat. Is just saying, ooh. So yes, we have 6 mono LED outputs with indicators. The board actually has indicators on it, so you can actually see without even plugging in the LEDs. There is a little indicator LED. If I put this under the other camera, you should be able to see this. If I just go to this one here, you can see that they're all sort of phasing in and out. We'll just put that the right way up. And there's also an RGB LED on there as well. See, that's changing colour. So that means you can actually test out your code without actually having the LEDs plugged in, which is pretty cool. 5 volts out for each of those. They're also connected to a GPIO pin via the RP2040, so it's very easy to program these individually if you've got a specific kind of animation that you've got in mind. The one RGB output connector actually can connect to a series. It works in the same way as a LED strips, so you get one connector, but that can actually drive multiple RGB LEDs. So I've got 6 of those plugged in at the moment. The audio output is a 3-watt I2S connector. So I2S driver, if you like, our audio outputs. That means we can play WAV files, which is pretty cool, and we can also do individual notes. We'll have a play on that in the demo in a second. The JST SUR connectors are for power in, so that's a very, very tiny, I've got one on here, very, very tiny connector. Just have a look how small that is. It's the kind of middle of the board. I get this too. Can you see there it says 5 volts? That's tiny kind of connector. So you might need some tweezers or something to get these in and out. It's USB-C powered, so you can program it or you can power it even. So I've currently got this just hooked up to the computer via the USB cable, so that's kind of just dangling out of the model at the moment. But I guess if you wanted this to be a kind of shelf model or display model, you might hide that or just have it battery powered. So yes, it's an RP2040, 4 meg of flash, plenty of space to have sound clips, more than enough space to have multiple programs on there as well. So you've got the RM2 for wireless. So what kind of things would you want to do with wireless? Well, you can actually have the sensor trigger, say, an MQTT server, so that can host. It can connect to all kinds of other things from that. So you can even have like your home lighting interact with your Lego model if you wanted to. All kinds of possibilities there with the wireless. And also the wireless provides Bluetooth connectivity as well, so you could control that from something like, have I got mine to hand? Just trigger the animation off there again. You got something like the gamepad, you could connect this and set up your buttons so you could trigger certain animations or sound effects or whatever from a remote control. So all kinds of things are possible there. Got the reset button, so you can just reset the board very quickly if there's a program crash or something. We've talked about the Quest connectors, and we've also got that sensor connector, which is specific to this particular board, which is a PIR sensor. We'll have a look at that in a second. So the inputs for the voltage is between 3 and 6 volts. So I've got a little battery pack here that's got 3, I think they're AAA batteries. I don't know if you can hear the sound effects keeps playing. So there's 3 AAA batteries there, so that's what, 4.5 volts, something like that. And yeah, the sensor and voltage in as well. So plenty of connectors and I/O there, but all connected via nice simple JST type connectors. So the LED lights, these are absolutely minute. So you can actually just glue these on with like a bit of blue tack, or you could use, what kind of glue have we got on here? That kind of Yoo-hoo type glue. We have Pritt Stick in the UK. That's that kind of white glue. PVA type glue. You could use a super glue if you wanted to, though if you do that you're never getting it off your Lego kit. So these are actually the RGB LEDs, these ones, just out of interest. You can see there these ones are between 5 and 15 5 or 15 millimeter lengths, centimeter lengths even, be quite small if it was 15 millimeters, and these are very, very tiny. So the idea is these are so tiny they can weave in between individual Lego blocks, and that's very easy to weave them into your projects and kind of hide the wiring and just have the LED where you want it to be. So we'll have a look at an example of that in a second on the model I'm working with. The expansion board is for the RGB LEDs, so you can plug it into one of them and it'll drive the rest of the lights on there. So you can have like 5 RGB LED strips, I think that is. And it's got an adhesive backing on it as well, so you can stick that onto your model and remove it quite easily. Cool. So working with noodle LEDs. So you might have come across these noodle LEDs. I've got a DeLorean model, the Back to the Future Lego model. I was thinking about putting some of these like blue noodles on. The entire thing lights up on the noodle. I'm just going to remove the power on that for a second so that it doesn't keep triggering that every time I wave my hand around there. So yes, these RGB LED noodles are a bit like neon signs, but they're bendable, so you can do all kinds of stuff with them. I've got a few of them somewhere, but not to hand. I should have got them out, but I've not actually got the connector, this noodle adapters, with me, so maybe we'll do that on a different one, depending on how popular this video is with people. And the sound, so you can play either 44.1 kilohertz or 48 sample rate wave files. I used Audacity to convert some files that I'd found on the web. These were some clips from the movie Jaws. And they weren't in the right format, so it's quite easy to load up Audacity. I'll show you how to do that if I remember in a second. And the speaker itself is the 8 ohm speaker, 1 watt max power, and it's surprisingly loud for such a tiny speaker. That also has a little adhesive strip, that white thing. You can just pull it off, stick that to your model, and away you go. And it has a very simple kind of connector on there that just plugs into the audio output. I'll just hold this up. Is that bottom one just there. So very, very simple to plug the speaker in and then get up and running with sound clips. This is the sensor. This is the PIR stick. So this is that sort of passive infrared detection. So it detects motion. You can wave your hand and it'll detect that you've done that. So you just need to position that somewhere meaningful on your project and model, so that when somebody approaches the model, it can then interact and play them a sound clip or some lighting or some combination of both of them. And that can also be expended with some cables as well. So I've got that on the mast of the ship that we'll have a look at in a second. So if you like this video, you want me to make more videos like this, then drop me a like and also drop me a comment. Let me know what your favourite Lego model is. Really interested to know what kind of Lego models people like. I always like the Technic kits myself. I always find the sort of mechanisms of those quite interesting. I also like the sort of fun ideas ones like this one as well. If you're not subscribed, also consider subscribing. It means so much to me and it costs you absolutely nothing. I also go live every single Sunday at 7 o'clock British Summer Time when we're in GMT. I'll also be in GMT. Cool. So, the Jaws Lego set. So yes, I recently turned 50. No way, Kevin. and Alex and Jen got me this amazing Jaws Lego set. You can see there at the Trafford Centre in Manchester, picking up the Jaws Lego set. It's such a fun kit to put together. And yeah, the movie Jaws was also released 50 years ago this year, so there's a bit of a hookup there between my age and the film Jaws. It's also one of my favourite movies as well. So I was gifted the Tiny Effects by Pimoroni, so they've kindly donated these just so I could showcase these, and also the single kit as well as the starter kit that they have there. We'll have a look at that in a bit more detail in a second. So yeah, I thought this would be a perfect combination to put the Tiny Effects, put some lighting and sound into a Lego kit, and I thought it'd be really, really fun to do. Yeah, the other bag has got the DeLorean in it, so I kind of maxed out my Lego allowance for the year. So I actually had the original Lego lighting kit back in the day. So I was a child of the 80s, and I had these yellow light blocks. There was 2 styles. This was the sort of second style that I had. There was even earlier style than this. And I believe the very first Lego lighting kit was the 995. That's the sort of kit number, and that initially launched in either 1966 or 1969. I couldn't get the exact date on that one. And that was just called the bricks with colour filters. There's all kinds of colour filters that you could put in front of the lights, so you could make a sign light up. And the thing that I always wanted to have, but I didn't actually get this one, and we had plenty of Lego. I've still got all my original Lego from 1980s in the loft. It's a great big sort of really useful box with that in. I also wanted the light and sound system kit as well. So this one, you can see there the fireman kit there. That one had the fire alarm sound, as well as the little blue LEDs that could flash on and off. I don't even know if they were LEDs. There might have been like bulbs back in the day actually rather than LEDs, similar with that, the yellow light thing there as well. So yeah, that required quite a big battery pack, and the wires were quite chunky. They weren't these like really small ones. It was quite obvious where you had the lighting, but really fun. So yes, that was a bit of retro Lego for you there. Right, let's get into a bit of a demo. I want to show you how all this sort of works. So I've got a couple of different views, and what I might think is the best way to do this is to go to this view here just for now. So I've got my my Orca kit just here, and inside the cabin is where the actual tiny effects kind of chip board is. So that's the Tiny Effects W, which has got the Wi-Fi capability on it. So that's in there. I've got a bunch of LEDs inside that cabin as well. On the mast here I have the PIR sensor, and I've also got my phone on a little tripod. Let me just grab this. Got it. I'll show you there. I've got my little handheld Insta360 thing, so I can move this around so you can see there on that top right one. You can see there, that's the PIR, and inside we have, just see there's a little board. If I just hold this and point, just there you can see the cable, and then on this barrel here, if you remember on the film Jaws, hopefully there's no spoilers in this because you know the film is 50 years old, but there's a little barrel there, and in the film they sort of shoot these barrels into Jaws. And they have these little flashy lights on them, so I thought that'd be quite a fun thing to kind of replicate. So I'm just going to put that back there and just move that around. Oop, there's Jaws. There's half of Jaws anyway. So it's really fun model to build, by the way. Definitely recommend this. I think it's about £130-ish to buy that. Cool. Right, so let's get to some demo code. What I'm going to do, I'm going to load up some code, and then we're going to go over to, let's go to this view. For now, so we can actually see what's going on. So let's go for the first one. Go over to here for a second, just to go through a bit of the code and how all this kind of works. I'm just going to plug the USB cable back in, because it was making lots of noise while I was trying to talk to you there. Right, so I just hit the stop start button. So you can see there, this is running a special version of MicroPython that's got the Tiny Effects libraries and everything pre-installed on there. So it's actually MicroPython 1.23, and this has got the build that sort of comes with the board. So yeah, the first one then, we're going to import Tiny Effects from Tiny Effects. That's a library which is installed on the board. You can see there we've got this Tiny Effects, and yes, Alex is saying, notice the hat there. And I'll just go in a bit of a tangent here. You can see on the back of the t-shirt as well, it says Jaws 50. Okay, let's get back to there. So yeah, we're importing Tiny Effects. We're importing from Pico Effects color. We're importing red, yellow, green, cyan, blue, and black. So that's a triplet of values for the different colors, the different RGB values for each of those. To make it easier, we can just say red, yellow, green, and they will work. We're importing pin from machine. We usually do that when we're interacting with pins, GPIO pins, and from Pimoroni we're also importing analog. This is for the sensor. Okay, so this is going to play some tones, and there's different volumes for each of these tones, different durations for each of these, and this is going to be put into a simple kind of music player, so we can actually hear some music come out. 10 points if you recognise which movie the sound is from. It's not Jaws. The RGBs, these are the different colours that will also synchronise with the notes as they're played. So we've got cyan, blue, green, red, yellow and black. Use the sensor is false, so we're not currently using this to trigger the speed of the melody. We've got speed is 20, samples is 5. We're not using those max speed values though, so that's fine. And then this is where the kind of magic happens. So we say tiny equals Tiny Effects. So that creates the Tiny Effects object for us to interact with the board. This index is just the index of the tones to play. That's going to start at 0, just at that 588. And you'll see what that's all about in a second. And then if use sensor, we're not using the sensor on this one, so this is fine. And then we've got this nice try and finally block. If I just scroll down, so try finally means it will always run this tiny shutdown. If you don't have that tiny shutdown, you get like a really weird kind of glitchy effect after it after it plays a sound clip I've discovered. So while not tiny.boot pressed, so this is until we press that boot button, it's just going to keep looping around playing this this set of tones. So tone equals tones index, that's going to be the first tone we've got in our little array, our little list, and the outputs is going to be the outputs. And the speed is going to be set to 1. So if we're using the sensor, then it would run that block. If we're not using the sensor, which we're not in this case, I'm going to say if tone, then tiny wave play tone, the tone, and then the volume index from the little volume index list that we have as well. Now, once it's played that, it's going to say tiny clear. That's going to clear the output for the next tone. And then if tiny outputs output -1 on. So what's that going to do? That's going to turn on the output for the next tone, right? And then we're going to set the RGB outputs to a color from the tone, and you can see there it's just going to unpack the RGB values from that index. That's what that star means. It means like unpack the values from the whatever's being returned there. It'll be like 3 values. Then going to sleep for a duration. It's then going to stop the wave from playing, and then it's going to pause between each tone. There was a little plus equals just means increment index by 1. So if it starts at 0, it'll then become 1. The next time it goes around the loop, then 2. And then if we have this percentage equals length of tones, this is going to make sure that we percentage index. Let me just refresh my memory on that one. I think it's like mod percentage index. I can't type that on there though. Percentage index Python. So there we go. I just want to make sure I get this information right. So yes, it's a moderator. So modulus, I should say. So modulus, and what this will do is it will call the remainder. So if we're incrementing this index and we've got to like a number that's higher than the length of items in the index, then obviously that would cause like an index error because we'd go outside the bounds of the index. But by using this percentage equals, we're doing a modulus, so it's essentially going to find what the length of the tones are, so how many things are in that tone list. So say there's 6 tones in there, it's going to say modulus of the length of tones, so it'll just chop off anything that's longer than that. It's essentially just going to reset it back to 0 when it gets, instead of using like an if statement, so if it's greater than the length of tones, set to 0 kind of thing. And then finally we're going to tiny.shutdown. That's going to shut down the tiny effects board. It just kind of cleans up any kind of outputs for lights or from sound. Right, let's actually play this, and I'm just going to move the microphone a bit closer to the model so you can actually hear this play. And I will also, not that you can see anything, but I'll go over to this view here just so you can kind of see what's happening at the same time. There's nothing going to happen light-wise, it's just pure sound. I just want to make sure you can actually hear this. So I'm just move the microphone there. I'm going to hit play. Of course, there are lights. So can you hear that? £10 points if you can guess the movie. So I'll just wait to see if people can actually hear that. If somebody can just comment on there if you could hear that. And then I'm going to stop that program. I'm going to move on to the next one. Adam's got it. Perfect. Good. That means you've heard it. And it'll keep doing that and keep flashing those LEDs there. So if I just run that again, you can see that the LEDs are sort of changing colour values in there. And there's one on the little barrel as well. Sort of flashes on. There we go. So that's just like a tone player rather than a wave file player. So let's go to the next one. So this one is a really simple program. So this one, from tiny effects import tiny effects, and then we say tiny effects wave root, which is the root, which is going to look at these 3 wave files here. So we can say tiny.wave.playwave biggerboat.wave, and then while tiny wave is playing pass. So this is basically just going to do nothing while that wave file is playing, because it's kind of, once it's triggered it, it'll carry on playing it and it'll carry on running your code. So unless you have something to make it twiddle its thumbs for a second, it will just move on to the next piece of code. And I've got these three. I've got bigger boat, abuse, and score, and then a tiny shutdown. So again, I'm going to move the microphone a bit clearer. Hopefully you can hear these. They are quite soft, and that's just the way that the clips were recorded. So I'm going to move the microphone once again and point it towards the speaker. That last one is quite quiet, but that was the theme from Jaws, played very, very quietly. So we can play WAV files, and if we open up, what I'm going to do, I'm going to open up Audacity, and I'll show you quickly how we can use Audacity to convert the WAV files. So just wait for that to open up. Okay, let's just skip that update. Click OK on that. So what I've got on here then is a bunch of WAV files. Let me just grab. Let's grab, is that one still actually on here? Right, I've got a clip here, and I've got my sound turned down. Let's just turn it up. Ahoy there, makers! So that's some kind of internet celebrity there saying ahoy there, makers! Ahoy there, makers sound. I usually say that at the beginning of Pimoroni videos. So if we want to save this so we could actually play it using the tiny effects, we would have to go to File, Export Audio, and then we need to pick on here, the sample rate is either 44.1 or 48,000 Hertz. So either of those will do. If you do the 44.1, it's slightly smaller. So unfortunately, it can't do any smaller than that. And we can also pick mono as well. And we could call this one Ahoy. And we could even save that in our project folder, which is the Tiny Effects. Not that one, the other Tiny Effects folder, which is there. We'll call that ahoy.wave. Let's export that. So now that I've exported that, I can go back over here. We can see we've now got this ahoy.wav. So if we go over here, we can just do another tiny.wave.play wave and then ahoy. Oops. And then let's just have that other while playing do nothing, and then hopefully when I press play on this, you'll hear this through the actual tiny effects. So let me just do this. Oh. I need to copy it to the board, of course. Yeah, I forgot to actually copy it, upload it to the board, but the board's got 4 meg of RAM, so that's plenty of space. Right, it's copied now, so we can play it. Ahoy there, makers! You're gonna need a bigger boat. Isn't that weird effect? That's what happens if you stop it and you've actually not closed out and done that tiny shutdown. So yeah, that can happen, and it can actually mess up the board. It seems to freeze out the board and you have to unplug it and plug it back in again. It's the only little glitch I found on there. Right, so that's the audio. So let's have a look at the sensor next. So the sensor is this tiny little, it's about that kind of size, little board that connects up to the tiny effects, and it allows us to passively infrared detect anything in front of the sensor. And it works for maybe like 30 centimeters or so. So if you wave your hand in front of the sensor, it will trigger it, and it will then detect that a person or something is present, and therefore it will then, you can detect that as a state. So if we look on here, we've got this we've got the usual tiny wave root, we've got the sensor equals analog, and then the pin tiny.sensor pin. Sensor pin is a constant which we can grab from the Pimoroni tiny library. Samples is just to do with the sample rate. Sleep 0.1 is how fast we want something to respond. And this minimum and maximum voltage That's to do with the sensor returns a voltage in effect, and we can then map that to percentage in our code. So we can see if it's above a specific percentage, then we can trigger our action, whatever that's going to be. So while not tiny boot pressed, voltage equals sensor read voltages, and then samples, that's just how many samples we're going to take to get that an accurate reading of the voltage. It's almost instantaneous, so that's not a problem. And then percentage equals, and this is a little formula for figuring out from that voltage between, so we have voltage minus minimum voltage divided by maximum voltage minus minimum voltage. That will give us a percentage, a value between 0 and 1, with 80 being 80% in this case. We then got a sleep, so it's just going to sleep in between doing these voltage readings, and that's going to be for a tenth of a second. We then have, if the voltage is greater or equal to 80%, then play the abuse.wav, which is that gotta take this abuse much longer. While tiny wave is playing, it's going to spin its wheels, and then finally it's going to shut down. So it'll only trigger if we actually, maybe we should have like a piece of code on here that actually prints something out. Let's just add that, just so we can actually see it on here. Action triggered, like so. Right, let's play this and see what happens. So nothing is going to happen until I trigger the code. So if I wave my hand in front of the sensor, action triggered, and he's saying I can't take that abuse much longer. There we go. I've got a message there. Jenny's saying we're going to Amityville next year. So yeah, we're actually going to, for Jenny's 50th, we're going to, is it called Jonestown? I can't remember the actual name of the place. I know it's in Martha's Vineyard. It's the actual town where they filmed Jaws, or Amityville. We're going to see that. My cousin actually lives on Long Island, where the Montauk is at the very end of there. They talk about that in the film quite a bit. I believe that's where the original, the story from the book was kind of based. Right, so that was how we get sound working, either tones being played or clips being played. So next up, what we want to have is how do we actually have animations of these lights. So one of the really cool things about Tiny Effects is they've created a whole effects library. So we don't have to create the animations ourselves necessarily. We just pick the type of animation we want, put in some values, and it will do the rest for us. So let's have a look how this works. So again, we're importing Tiny Effects. We're importing the color player, so this is going to help us play some color effects. In this case, it's going to be this flickering effect. Then the Pico effects color is just grabbing some color, the actual color effects itself. So there's the player that plays the animation, and there's the type of animation that we want to play. So RGB flicker effects will help us get this kind of flickering lantern effect for our cabin. That's what I've gone for there. So this color value here, 2551280. Does anybody know what colour that is? Let me know in the comments below. So tiny equals tiny effects, player equals color player, and we pass in the tiny.rgb, so it'll play the control via the RGB outputs rather than the mono outputs for the monochrome LEDs. And then we set up the actual effect, so we pass in some values. So player.effect equals RGB flicker effects. Colour is going to be the colour that we want to be flickered. The brightness is the maximum brightness we want to use. The dimness is the minimum value we want to have for that brightness. The bright min, bright max is the amount of time we want them to be at those values for. And then similar with the dim, so how long do we want it to be dim for min and max. And then we simply say try start. So player start, that will start the effects playing. And our code can do other things while that's happening. So it kind of has that running in the background, if you like. So in this is player running block, and tiny boot pressed is not being pressed. We can put any other code that we want in there. And then finally we've got the player stop and then tiny effect shut down. So if I now play this one, I'm going to go back to our multiple view there. Let me just get that there so we can see the cabin. I've turned down the studio lights on this so you can see the lights a little bit better. So if I press play, you can see in the little window there, you can also see from the back. So if you're looking at the bottom left, that one just there, you can see the lights flickering. And if I also look at the top, you can see the RGB lights flickering in there as well. So that's just the Yellow is the colour that was. So that's how we do kind of effects. So I could have all other kinds of code running on there, and it's just going to carry on doing that same effect until we tell it differently. Okay, so I've also got a monochrome LED on the top of this barrel here, and on the next one, so it is gold. Goldfinger says orange. Yes, it's kind of a yellow orangey colour. Absolutely right. Cool. So the last code that I've got on here, let's go back to our code, is orca.py. So this is my attempt to make some kind of interactive thing using this model. So kind of bring all together the sound effects, the lighting effects, and the sensor as well. So let's go for this one. So we're passing in, creating that little tiny object, which is tiny effects, with the wave root being the root of our file system over here. So it can see abuse, ahoy, bigger boat, and score. The player is going to be the color player, so we can play those RGB LEDs in that nice color that we've got there, that sort of orangey yellow color. And set up the sensor so we can actually detect things with our sensor. And we've setting up that RGB flicker effect exactly the same as we did on the previous one. So then we say player start, we're going to say bigger boat, so you're going to need a bigger boat is the first sound clip that plays, and then while it's playing nothing else happens in there, so it's just going to wait until that sound clip is finished. We could also have the score playing after there if we wanted to. I've just commented that out for now. And then while player is running and the tiny boot is not pressed, we can have the this little animation, so 6 on, 6 off, 6 on, 6 off. That's like the sixth. So where we have on the tiny effects board here, we have 6 monochrome LEDs that are controllable there, and they're accessible by the sort of number. So tiny.1, you can say tiny.1 to on, tiny.1 to off, and it'll simply turn it on or off, and you can have like a sleep between them. So what I wanted there was to make it just do like a flash flash and then wait, and then flash flash and then wait. So it does a flash, it turns it off for a tenth of a second and then flashes it on again and then turns it off. So it's like really quick kind of double flash, just like in the movie. We then read in the voltage, we work out the percentage of that, and then we sleep, and then we say if the voltage is more than 80%, play the abuse sound effect. Otherwise we just and while that's playing we just do nothing, and then we sleep for another second, just to give it some breathing space. Now what we could do if we wanted to be really clever is we could bring in random. We could have a list of all the different sound effects that are replayable, and then we could randomly pick one using the choose keyword. So let's just run Orca and kind of have all this come together. So let's go back to here, hit play. So you just said you're going to need a bigger boat, and you can see now we've got that nice double flash. I'm trying to show you without getting in the way. So depending which one, I think the bottom right one kind of captures it better. You can see the double flash there. And we've got the nice flickering effect in the cabin as well, and if I wave my hand, we get that little sound clip play. I'm just going to move my microphone one more time. So really cool. I've probably really not done a great model, but I wanted to bring this particular one to life with tiny effects. There are so many other Lego models out there that are just dying to be brought to life with tiny effects. So I'd be really interested to know, what model do you think we should do next? I've got the Transformer Optimus Prime Lego model, and also the DeLorean Time Machine one as well. They'd be very easy to add some tiny effects to. I didn't talk about the price of tiny effects as well. I'm just going to bring up the pricing on Pimoroni's website, because I think that would be quite cool to actually understand what we're looking at there. So I'm just going to go back to me for a second, grab a web browser, and let's just bring that down so you can actually see what's kind of available in the whole range. Cool. Right, so if I just go over to here, this is oh, just close that other window out. Sorry, let me just close all those out. And then let's go to, just close all those out. Sorry. that one. There we go. So it should just have, there we go, Pimoroni website. Sorry about that. So you see over here we've got Tiny Effects. Let's click on that and we can see the whole Tiny Effects range. So there's the LED noodles. Each of them is a single colour, so you just need to pick which colours you want. So that's £6.90 for a pack of 5. They have a taster pack as well, which is 6 slightly shorter ones. There's the speaker, £1.80 for that. You can get a pack of 6 Tiny Effects LEDs, so they're £3.90, so they're pretty cheap. You get a USB cable, USB-A to USB-C. There's red noodles, yellow noodles. There's the actual starter kit, so that's the one which I have just here. That comes in this little kit box, and that has all kinds of stuff in it. So it has the speaker, the USB cable, the LED dots, the RGB LED dots, and the battery pack as well as the actual Tiny Effects. And this is the Tiny Effects W, the wireless version. We've also got the blue LEDs there. You can see they're £9 for a pack of 5. The LED dots, £3.90, so they're really, really affordable. We've got the PIR sensor, that's £7.50. The board on its own is £19.50. £90.50. And they've got some other different ranges of stuff there as well. There's the Tiny Effects LED Effects Controller Starter Kit, £30. That's just the stuff without. Is that with or without? Yeah, with the little board. You can just see it there. And then you've got other things like a USB power cable. So if you don't want to have a battery pack, you want this to be permanently plugged in, there's a USB connector to the tiny little battery connector. And you can see there we've got just the board. Board only is £15. That's the non-Wi-Fi version. Got the battery box, £1.80. The little ports for the RGB LEDs. Oh, that's for the mono LEDs, sorry, that one there. So the £3.90 for the little expansion board. And the LED strips, £6 for warm white. And they've got all kinds of other LED strips as well. £6 each for those. And then the little noodle adapter, they're currently out of stock, but they're £9.90. I think there's even more stuff under here as well. There you go. Some 2-pin cables for the Tiny Effects pack. Triggering the effect thing as well. There we go. Cool. So let me just close that out and go back to over here. And let's get back to our slides there. Cool. So I hope that was quite a fun thing for you to see. If you've not joined our Discord server, we have a really great community over on Discord, kevsrobots.com/Discord, to get a free sign-up link. Just pop in your email address and take it from there. Just check your junk mail if you do that. If you want to follow me on social media, I'm on all the social media platforms. So on Threads, I'm at Kevin McAleer at threads.net. On Twitter, on TikTok, I'm at Kevin McAleer 6. On Instagram, at Kevin McAleer. On X, I'm at KevsMac. On Mastodon, at kevsmac at mastodon.social. And also on Blue Sky at kevsmac.bsky.social as well. So you can check out on there. If you're on there, drop me a follow and say hi. Show me kind of what you're working on at the moment. I'd be very interested to see what kind of projects people are working on. Mute that as well. And if you want to follow me and support what the content that I do and get your name in the end credits, then you can just go over to kevsrobots.com/coffee to do exactly that. We've got the Buy Me a Coffee. You can buy an individual coffee if you want. I'm a big coffee drinker, as well as a Diet Pepsi. And you can buy an individual one, or you can do like a monthly subscription for the price of a coffee. And that's sort of outside of the YouTube ecosystem, or you can go to the join the YouTube membership as well, and there's a couple of different tiers on there as well. So I'm going to show you some people who've done exactly that. So over here we have the Buy Me a Coffee people. So Marie Louise Mayer bought me 3 coffees. Thank you very much for that, Marie, really appreciate it. And someone who wanted to be very nameless bought me a coffee as well. There's another anonymous person, member, and we have Silicon Fiber, Marie TKD. We have Jeff Johnson, Deanne Corty, Marlene Brent, and Tom. Thank you all for being continual supporters. And then over on the YouTube side, we have Justice. We've got Pierre Yves. Is that the Balachet? I'm not very good with French names. We've got Oxford 39, Bert. We have Marie, Michael, Steve, Ford, Bello, Johnny, Stephen, John Paul, Cassie, Tinkering Rocks, Johnny Bates, and of course we have Tom. Thank you all for supporting the channel. It really means so much to me that you do that. If you're not subscribed, please subscribe. It means so much to me that you do that. Cool. So let's go over here. So yes, we've done the supporters bit. Yes, so the spinny logo tells me it's this point in the video where YouTube will be recommending over here another video for you to watch. So definitely check out that video. It's been handpicked by the algorithm just for you, and it thinks you'll find this one really, really awesome. So this is the point of the video. I'll say thank you so much for watching, and I shall see you next time.